Hello everyone. So this session is for revising your upcoming summative portions. So I welcome all of you. So I can see. Hello everyone. So this session, few people are there already. So let me see who all are there. So I can see Ronak, Kirtana, Mansi, Arpita, and Ruhi. Yeah. So I believe you have 3 topics in this upcoming exam. If I'm not wrong, linear equations, matrices, and rational expressions. Is it so? So I have received a couple of questions from Arpita. I would request all of you to send a few more if you have any, or we'll just do a quick recap of all the topics so that you are in sync with the the syllabus. So I'll give you a few. You can either post it here or you can also post it on the WhatsApp group, whichever way you want. But do post your query so that we can, we can have a very specific revision. Yeah. So Arpita asked me, if I'm not wrong, she asked me about additive inverse. What I can see is, yeah. So Arpita, can you just emphasize? You can, so you wanted to understand what is an additive inverse. What was the question? Question is the second sum. Second sum says, okay, Neha is also there. Good. So basically, additive inverse is nothing but, you have to find. So what is an additive inverse? Let me write it here. So yeah, so I will share the screen so that all of you can see what I'm writing, the whiteboard. Yeah, so I think now you will be able to view my screen. Yes, so let me go to full view. Yeah. So additive inverse. Let's take this topic first. Additive inverse. So additive inverse. So Arpita wanted to. She shared a few questions. Now the question was, and Arpita, if you want to send any information, you can always do that on WhatsApp. So basically, the question was, if I'm not wrong, that's what she asked. What's the additive inverse of? What's the additive inverse of a square plus 1 by a square minus 1? Okay, so this is given. So you have to find out the additive inverse of this thing. Now, additive inverse is nothing but, so additive inverse, let's say that, let us say that, let the additive inverse of a square plus 1 by a square minus 1 be x. Now, the property of additive inverse says that if you have additive inverse, if you add the expression and its additive inverse, you will get 0. That's additive inverse. Okay, that's additive inverse. So if you see, additive inverse of 2 is minus 2. Why? Because 2 plus minus 2 will give you 0. Okay, so hence you can find out what is x. So x is, what is x? Yeah, so x is, so x will be nothing but negative of a square plus 1 by a square minus 1, which is simply a square plus 1 by 1 minus a square. That's it. Which sum, Neha, Arpita, if not this one, then which one? Second sum. This was the second sum, right? And then you also sent me another one. solve what? The other question was 28 and 29. So 28 is x cube. Okay. So next question was to related to factorization. Okay. So hence next sum was this. So question is, I believe, how to factorize basically, right? So question number 28 says x cube minus 19x plus 30. Okay. Plus 30 and then divided by x square minus 3x minus 40. So this one is x square minus 3x minus 40. So basically you have to factorize this. Now Arpita says last step not clear. Which step, Arpita? This one? X equals, so this is so basically this one is x equals to minus a square plus 1 divided by a square minus 1. So hence you have to just take the negative sign, multiply by negative 1, so the denominator becomes 1 minus a square. Is that the last step you're talking about? Yeah. So when this negative sign is, let's say taken in, so this negative sign when goes and let's say multiplies by the denominator, it will give you 1 minus a square simply. Okay, so here is the next sum where we have to factorize this basically. So now one way to do it is, see clearly what comes to our mind when we see such kind of a problem. Clearly this is not a quadratic polynomial, it is a cubic polynomial, and we know that for quadratic, if had it been quadratic, we could have used the split the middle term, and if this doesn't work, then we can always go for the quadratic formula and find out the roots. Quadratic formula, we can always go to the quadratic formula thing and we can find out the roots, but here it is a cubic expression. So one trick is to see what is the root of the denominator, because at the end of the day there will be, so what will be this numerator will be something of this sort: x minus alpha times x minus beta times x minus gamma. The numerator will be expressed like that, and then let's say the denominator will be of the form of x minus a times x minus b. Now clearly one of the factors have to be cancelled out, right? So one of x minus alpha, x minus beta, x minus gamma will be there as x minus a or x minus b. So in such cases, what we do is we try to find out the roots of the denominator, because clearly we'll have two roots here because it's a quadratic polynomial, right? So hence clearly first go for this and try to find out this. So clearly if you can split the middle term, and if you see denominator is nothing but minus 3x and this is minus 40. So one thing which comes in mind is, so how do you split that middle term? Minus 40 can be written as 8 into minus 5 or minus 8 into 5, right? And the sum minus 8 and 5 is minus 3. So hence I got the denominator. So denominator is x square minus 8x plus 5x minus 40. Okay, so this is nothing but x times x minus 8 plus 5 times x minus 8. So this denominator is simply x minus 8 times x plus 5. Okay, so now the trick is definitely one of the roots, most certainly one of the roots of numerator will be either 8 or minus 5. So what are the roots here? Sorry, roots of denominator. Roots of denominator are what? 8 and minus 5. So one of them definitely be the roots of the numerator. And best practice is to check. Let's put minus 5 and check. So if you put minus 5, so hence if either 8, if this 8 or minus 5 is the root of the numerator, then by factor theorem f of that root must be 0. So let's put minus 5 in the numerator. So let's say minus 5 in the numerator will give you minus 5 cube minus 9 into minus 5, and this will be 30, isn't it? So do you think it is going to be 0? Let's check. So minus 5 cube is minus 125, which is not possible, maybe possible. 125, and this is 19 fives are 95, and this is plus 30. Perfect. So it is coming out to be 0. That means minus 5 is the root of that. That means what do we say? Minus 5 is root of the numerator. Root of numerator. That means x plus 5 is going to be a factor of x plus 5 is going to be a factor of numerator. So when I know that x plus 5 is a factor of numerator, I can find out the other factor. How? By dividing the numerator by by x plus 5. So let's divide. Okay, so division will give you x square. This is x cube, and then this was plus 5, so plus 5x square. Okay, and you subtract, this becomes negative, so it is minus 5x square plus minus 19x plus 30 comes down. Okay, you do what again? What do you do? Minus 5x now. So next is minus 5x. So you'll get minus 5x square, then plus 25x, isn't it? Plus, yeah, 25x, and then simply that. So hence you cancel this out. So this becomes plus, this becomes minus, this goes. So hence this becomes 25 and 19. Minus 25 minus 19 is minus 44. Minus 44 x plus 30. Oh, we did something wrong. Wait. X square, x cube minus 19x plus 30. So x square gives you x cube and plus 5x square. Oh, I'm sorry. Actually, this is the wrong step. Wait a minute. I did a calculation mistake. So basically, draw the eraser. Yeah, this was a wrong step here. Yeah, so hence, yeah, so let's, so basically it will be, minus, right? Because it will change sign. So 19 plus 5, 24, minus 24x square. And this is, oh, I'm sorry, I did the, I'm again, but it will be a negative sign only. So minus 5x square now. Am I right? Minus, wait, no. What is happening? We are doing a wrong division. Wait a minute. My note is also not functioning well. Wait a minute. View. Yeah, now it's perfect. Now wait a minute. Okay, so let me erase all this. Draw eraser. Yeah. Yeah. Now, so hence first was x square clearly. So x square, and this is plus just to avoid confusion. So it is x square plus 5x square. Okay, and then you subtract it, so you'll get minus 5x square, and then minus 19x comes down, and plus 30. I hope now we are doing right. Okay, minus 5x square minus 19x plus 30. Perfect. Now minus 5x is multiplied, so minus 5x square you will get, and then plus and minus 5 minus 25x plus 30. Okay, minus, sorry, this 30 is not there. Yeah, so hence what happens now? You have plus here, so 25 minus 19 is 6x plus 30. And this is nothing but plus 6. So you'll get 6x plus 30. Perfect. So this goes. So what do we see? We see another factor which comes up, x square minus 5x plus 6. That means what? Yeah, so hence now I can say that x cube minus 19x plus 30 is equal to x plus 5 times x square minus 5x plus 6. Now you can split the middle term and you'll see this is nothing but x plus 5 and this is x minus 2 and x minus 3. This is numerator. And what was denominator? Denominator was simply x minus 8 and x plus 5. So you simply divide this by x minus 8 and x plus 5. Right? So this x plus 5, this x plus 5 goes. So you are left with x minus 2, x minus 3 upon x minus 8. This is the solution. Okay, I hope you got it. So this was question number, first question. Then next one, she said 29, and 29 is similar, but the only difference here is now both numerator and denominator has the same power or same degree. That is, both of them are cubic. So now second question is x cube minus x minus 6. So x cube minus x minus 6 divided by x cube minus 3x square plus 4. Now x cube minus 3x square plus 4. How to factorize? So x cube minus x minus 6 and x cube minus 3x square plus 4. Okay, again, yeah, here is where, you know, both numerator and denominator are not quadratic. So forget about splitting the middle term or any other formula to be applied. Here, what you have to do is you have to somehow find one of the factors, and if one of the factors is known, then you can get a hint. Okay, so usually people try, you know, this thing, you know, where let's say you put x equals to 0. So if you put x equals to 0, you see what is a root basically. So you can take help of, you know, graph, knowledge of graph. So if you see, if I put x equals, let's take the numerator. So if you put x equals to 0, it gives you minus 6. So this will be the point. Let's say this point is 0 comma minus 6. And if you put x equals to 1, you will get 1 minus 1, 0, and minus 6 again. So 1 comma minus 6 somewhere. So this is 1, and yeah, so let me just erase this. Yeah, so this is 0 comma 6, this is 0 comma 6, 0 comma minus 6 rather, and let's say this is 1, so this is 1 comma minus 6, 1 comma minus 6. Yeah, and then if you take 2, x equals to 2, so what's happening? You know, the curve is somewhere here, the cubic equation is somewhere lying. So hence, what will be the 0? 0 will be that part where the curve goes and hits, or let's say, you know, touches x-axis. So put x equals to 2, and thankfully you get 0. So that means x equals to 2, x equals to 2 here, the curve is becoming 0, x equals to 2. That means clearly x equals to 2 is the root of numerator. That means by factor theorem, x minus 2 is a factor. Now this gives you a hint. So if x minus 2 is a factor of numerator, it may so as well be a factor of denominator. Let's check. So if you put 2 there, you'll get 2. So let's say if in the denominator, if you see x cube, so in the denominator, x cube, right? So you put 2 cube minus 3 into 2 square plus 4 is actually 8 plus 4, 12 minus 12 is 0, right? That means luckily x minus 2 is also a factor of denominator. That means now you can find out the other factor by dividing again. So x minus 2 divides, let's say, x cube minus x minus 6. Okay, let's try and do this. So hence, clearly here it will be x squared. So x times x squared is x cube, and then minus 2x squared is an extra term, minus 2x squared. Now subtract. So x cube goes, this becomes 2x squared plus, because this will become plus, and then minus x minus 6. Okay, then you multiply this by 2x. So it is 2x squared minus 4x. Yeah, and simply that. Now this goes and this becomes plus. So plus 4x minus x is 3x minus 6. That means you can multiply this by 3 and this will get you 3x minus 6 and hence 0. So that means clearly x square plus 2x plus 3 is a factor. So hence numerator x cube minus x minus 6 can be written as x minus 2 and simply x square plus 2x plus 3. Now this cannot be factored. It cannot be factored further. Why? Because this doesn't have any real roots. So if you see, x square plus 2x plus 3 is always greater than 0. Always greater than 0. Why? Because x square plus, you can check like that whether it will be factored or not. You check the discriminant. Discriminant is under root b square minus 4ac. B square is 4. B square in this case is 4 and minus 4ac. 4 into 3, 12, which is a negative number. Right? So 4 minus 12 is negative. So that means no real solutions, no real roots. Right? So imaginary roots. Imaginary roots. So hence there will not be any further factor of this particular item. Hope you understood. What I'm saying is, let's say you have a quadratic expression and if you want to know whether it can be factored or not, what you can do is find the discriminant of that quadratic polynomial. If the discriminant is coming out to be 0, sorry, this root was not there, so b square minus 4ac. So b square minus 4ac is less than coming out to be 0. Let me remove this root sign. Yeah, so if b square minus 4ac is coming out to be 0 or less than 0, then be sure that it cannot be factored further. So this works. Now for the second one, you can again divide and find out. So let me, yeah, for the second case, what was the second polynomial? X square minus x cube, sorry, x cube minus 3x square plus 4. So divide by again x minus 2 because x minus 2 happens to be a factor of this. So clearly x squared, so it will give you x cube. Then minus 2x square is here. And then what will happen? This goes and this becomes plus. So hence minus x square comes down and plus 4 comes down. Now next is again you have to multiply this by minus x, I believe. Yeah, so minus x and times x is minus x square, and then minus plus 2x, so plus 2x is here. So this goes and then this becomes minus, so it becomes minus 2x plus 4, and hence simply you'll have to do minus 2 and you will get, wait a minute, you will get, yeah, and you will get minus 2x plus 4 here. So right, so hence my denominator is x cube minus x square minus x minus 2 into x minus 2 is equal to x cube minus 3x square plus 4. Right, so from the numerator and the denominator, if you can see, x minus 2 is common. If you see this this x minus 2 is common here in numerator and denominator, so you can cancel them, and hence it becomes x square plus 2x plus 3 by x square minus x minus 2. So this will be the answer. Okay, yes, this can be further, if you see, x square minus x minus 2 can further be reduced because you can split the middle term here in terms of minus 2x and plus x. So you will get x minus 2 into x plus 1. X square minus, you can further split it, and this is nothing but x minus 1, x plus 1 and x minus 2. Right, but then this is in the most reduced form. Yeah, so Ronak is asking, can we use factor theorem? Yes, Ronak, we are using actually factor theorem only to find out the factors. Okay, now, so next one is Ronak's. Arpita, could you understand the problem? So what is the learning? Let me just recap. Learning is whenever you find such problems, let's say if it is quadratic, very clear-cut learning. Clear-cut learning is, so let me jot down the learning. What is the learning in such type of problems? First, If it is a quadratic expression, no problem. No problem. Why? Because either you can go for splitting the middle term. Mostly it will be splitting the middle term only. Midterm. Or you go for quadratic formula. Correct? If it is not quadratic expression, let's say many a times it can be converted. So other could be, let's say, not quadratic expression, but easily transformed into one. This could be another type. For example, let's say if you have expressions like x to the power 4 minus 2x square plus 1. This is not a quadratic expression, but it can easily be transformed into 1. How? It's x square. If you see carefully, then 2x square, then plus 1 square, which is nothing but x square minus 1 whole square. Okay, so it was reduced to a quadratic form, and then it can further be x square minus 1 can be written as x minus 1, x plus 1, and there is square on both sides, both of them. So be careful. If you're getting a pattern like that, then if it is a biquadratic, it can be reduced. They can also give you like this. So x to the power 4 minus 5x square plus 6. Again, this is not in quadratic. This is not a quadratic expression, but it can be reduced to by what? Assuming x square to be one entity, so it becomes x square minus 5x square plus 6. So if you put x square as, let's say, y, so you will get y square minus 5y plus 6, and then now you can split the middle term. So you will get y minus 3. Sorry. So you will get y minus 3 and y minus 2. Okay, so y was x square, so you can simply write x square minus 3 and x. So be careful. So even if they are not quadratic expression, they can be transformed into one. So be careful about this. Third type is the one which we just learned. So third type is not quadratic as well as not reducible also, as well as not reducible to any quadratic form. So we just saw above, this equation expression where we talked about x cube minus 3x square plus 4 and all that. So in that case, what will you do? You will use factor theorem. In such case, you will use factor theorem. Factor theorem means what? Try and find out one root. You may have to use trial and error a bit, but your sense of graphing can help you there. So try to find out one factor. The moment you get not one factor, try to get one root. The moment you get one root, then you know that x minus, let's say this root is alpha. So the moment you get that, factor theorem says x minus alpha will be the factor of that. The moment you get the factor, then divide the expression by obtained factor to get other factors. Same exercise you do with denominators and you will be able to reduce it. So keep this thing in your mind. Okay. Now, next question is Ronak. Ronak has said something. What is this? What is to be done in this, Ronak? This is to be simplified, is it? So there are two questions. Okay. The question is, find this. Question is, wait a minute, just let me. So the question is 1 upon 1 plus x, 1 plus x square, okay, minus 1 upon 1 minus x plus x square, okay, plus 2x upon 1 plus x square plus x to the power 4. Okay, so this is the question. Okay, very good. So clearly none of the denominators are factorizable. None of the denominators are factorizable, but then it gives me one indication, one sense that, okay, where do I see that 1 plus x square? If you see, I have seen this somewhere here. So x cube minus 1 is x minus 1 x square plus x plus 1, something of that sort. And then similarly, x cube plus 1 is equal to, what is it, x plus 1 and then x square minus x plus 1. So I don't know, but it is actually guiding me that, so x square plus x plus 1 is x cube minus 1 upon x minus 1, and x square plus minus x plus 1 is x cube plus 1 upon x plus 1. Okay, so maybe we'll see. And then similarly, 1 plus x square plus x to the power 4 plus x square plus 1 looks like it is x to the power x square cube minus 1 upon x square minus 1. Isn't it? Am I right? X square minus, yeah. So this is it. So now let's see if we can use this somehow. So okay, where is it? Yeah. So let's say this will become 1 upon this will be x minus 1 by x cube minus 1, and this minus is x plus 1 upon x cube plus 1, and this is 2x times x square minus 1 upon x square cube minus 1. Yeah. So isn't it? Or then what can I do is I can write this as x minus 1 by x cube minus 1 minus x plus 1 by x cube plus 1, and then this one I can write plus 2x x square minus 1, and in the denominator I can just swap it, x cube square minus 1 I can write. Why did I do it? It's very intuitive, so let's carry forward. So x minus 1 x cube minus 1 minus x plus 1 x cube plus 1 plus 2x times x square minus 1 upon x cube minus 1 and x cube plus 1. Okay, so now it looks like a little bit easier. So now LCM will be simply x cube minus 1 times x cube plus 1, because there are this factor is there, one factor is this, another factor is this, and the multiplication of both. So LCM is simply multiplication of this. Okay, so let me, now, so if x cube minus 1 is already present, so this will be x minus 1 times x cube plus 1. Okay, and then minus x plus 1, and x cube plus 1 is already present, so it will be x cube minus 1, and then this will be simply 2x and multiply. Let's open it up. So 2x cube minus 2x. Okay, let's simplify now. So this is If you open it up, it will be x to the power 4 plus x minus x cube minus 1 minus 1. Then this will be simply minus x to the power 4, then x into minus 1 is minus x, then multiplied by minus 1 is plus x, then 1 into x cube, it will be minus x cube, and minus 1 is plus 1. Okay, and then this is 2x cube minus 2x upon x cube minus 1, x cube plus 1. Okay, if you see, just let's check once more if the calculations are correct. So x into x cube, x4, x into 1, x minus x cube minus 1, and then minus x to the power 4, and then minus, so minus x into minus 1 is plus x, and minus 1 into x cube is minus x cube, and minus 1 into minus 1 is plus 1. Perfect. 2x cube and minus 2x. So if you see, this item goes, and minus x cube, and 2x cube goes, and then plus x and minus 2x goes, 1 goes, minus 1 goes, it becomes 0. Okay. 1 2 by 3 minus 1 by 3. Yeah, correct. Yes, it is 0. Okay, so Ronak, what is the learning? Okay, I could solve, but that's not a thing. You should be able to solve, and the learning is, let's write learning. Learning is, how did it strike to me that I have to write like that? And it is purely by my knowledge of identities. Identities. The moment I see something like 1 plus x square, it gives me that sense of, so you have to be thorough with these identities. For example, a cube minus b cube is equal to a minus b, a square plus ab plus b square. And then the only next step which I had was, instead of b, I kept it as 1. And then you have to, these things you have to know. So the moment I see such kind of an expression, the first thing which strikes my mind is, this is nothing but a cube minus 1 by a minus 1. And similarly, I told you, right, though this is not a quadratic this thing, but I can always, so whenever you see such, geometric progression we discussed, right, it's kind of a geometric progression. So in such cases, you know that it can be reduced to by how? So 1 plus x square plus x to the power 4 is nothing but 1 plus y square again, where y is x square. So these two things were important to, and I really didn't know whether I will be getting 0, but then I started with that information, and as I kept on solving, I got some similar terms, and then I could use that. But other thing is something called brute force method, where you multiply all the 3 denominators and then take once LCM taken, then you do a full long multiplication. What I'm trying to say is, you can multiply this. So in the denominator, this into this will be there. And then in the numerator, if it is 1, then this into this, then minus this into this, and plus 2x times this into this, like that. But that's like a cumbersome and huge, and then calculation error prone. Ruhi, how do I know that you have to approach like this? Is again, so you have to have a keen observation. So whenever you see such things, so henceforth, let's say this is a data point for you all that you might not be knowing. Let's say, this is not that I am super intelligent or something, because I have seen, or over a period of time, I have seen that 1 plus x square is always, the moment I see such expressions, the first thing which comes in my mind is that it can be reduced to this form. So henceforth, you also remember that whenever you see such things, you remember. And it need not be the case that you will strike gold all the time. Yeah, but then at least you know where at least one direction is there to start off and to move in, and hence so that's why it is emphasized on that you should practice multiple types of problems and multiple number of times. When I was in your grade, probably I would have struggled myself. So don't panic. But now that you also keep that in your mind that this is also one of the ways to approach such problems. Let's go to the next one. So what should be added to 4x upon x square minus 1 to get something? Okay. So let me, yeah. Question sent by Ronak. Question. What should be added to 4x upon x square minus 1 to get x plus 1 and x minus 1. Okay, so simple. What should be added to 2 to get 4 is 4 minus 2. So hence what will you do? So that number is nothing but, or that particular thing is x plus 1 by x minus 1 and minus 4x by x square minus 1. This should be added to 4x by x square minus 1 to get this simple. So hence let's write x plus 1 upon x minus 1, and the moment I see this x square minus 1, the first thing which comes in my mind is you write it as x minus 1 and x plus 1. So what you do now, you can take x minus 1 from denominator as common, so I can write 1 by x minus 1, and within brackets I can write x plus 1 minus 4x upon x plus 1, isn't it? Which is nothing but 1 upon x minus 1, and then this becomes x plus 1 whole square minus 4x upon x plus 1, isn't it? Which is nothing but 1 upon x minus 1, and this is nothing but x square plus 1 plus 2x minus 4x upon x plus 1, which is nothing but 1 upon x minus 1, x plus 1 in the denominator, and here it is plus 2x minus 2x will get you x square plus 1 minus 2x, which can be written as x minus 1 whole square by x minus 1 x plus 1. So it is nothing but this square goes, this goes, so it is x minus 1 by x plus 1. So this is the answer. So if you add x minus 1 by x plus 1 to x plus 1 by x minus 1, you will get this, right? So what should be added? So onto this, you add this, you will get this. Fair enough. So that's solved, I believe. Yeah. Any other question, guys? Oh, yeah. Anything else? Hanji, please send your query. Otherwise, anything else you want me to discuss, please write it on the comment section. So I think linear equations, you should not be having any trouble, I believe. Linear equations we have done multiple number of times. Any other thing which you want to take up so that problems. Okay, problems. Let me give you some problems to solve. Problems to solve. Give me a moment, please. Okay, so do this. So the question is x cube, wait, where is it? X cube minus 2x square minus 7x plus 14 divided by x square minus 5x minus 14. Yeah, do it. Solve, simplify. In additive inverse, can the minus be multiplied to numerator or denominator? Anyone, Arpita, anyone. You can, but only one, not both. So you can multiply negative sign to any of these. Another one is another. This is 14. Okay. Question. Another question is minus x cube minus 5x square minus 5x square minus 2x plus 24 divided by um, divided by um, just give me a moment. So it is it will be 7x 12 minus minus x square plus 7x minus 12. X cube minus 8x square plus 19x minus 12 plus 7, 19. Yeah. So hence divide by, where is it? Yeah. Divide by x cube minus 8x square plus 19x minus 12. Yeah. Solve this. Um, x Another question is what happened? First one not done yet. Yes. Any breakthrough, guys? First done. First done. Okay, so what is the answer to the first? What are the roots of the first one? Numerator of the first? What is the answer to the first one? Yeah. So 2 and 7. No, 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 no. 2 and 7 are not. Something else. Check again, Arpita. 2 and 7 are not the roots of the. Yeah, anyone else? 2 and 7 is not the root, or are the roots. 2 and minus 7 rather are the roots. Okay, so what did I tell you? So in the first case, you first of all factorize the denominator. So if you see denominator is nothing but x square minus, split the middle term, you'll get minus 7x plus 2x minus 14. So this is nothing but x minus 7 and x plus 2. Yeah, so x minus 7 and x plus 2. So that means 7 and 2 are the roots. So check if 7 and 2 are also the roots of the numerator. So if you put 2, so numerator becomes numerator. Put x equals to 2. You will get 8 minus 2 into x square. Again 8 minus 7 into 2 is 14 plus 14, which is 0. That means 2 is the root of numerator as well. That means x minus 2 must be a factor of numerator. So you can find out the other factor by dividing. Let's find out the other factor by dividing. So this is 14, guys. Yes. So hence it will be x squared. So you'll get x cubed minus 2x squared. Okay. So if you multiply x squared, you will get x into x cubed and minus 2x squared. So both gets cancelled. Okay, then what do you do? Minus 7x. So hence minus 7x comes down plus 14. So it is minus 7. If you see, am I right? So minus 7x plus 14. Yes. Something is wrong, I believe. I don't know. X minus just a moment. X2 minus 2x square minus 7x plus 14, correct? So x into x plus 2. Yeah. So what is the issue? So let's say x minus 2. So if you multiply, should I get the top one? Doesn't look like. So x square. Okay, never mind. So x square minus 7. So yeah. So let me see. X minus 2 times x square minus 7. is what? What would you get? X cube minus 7x minus 2x square plus 14. Yeah, you're getting it. X cube minus 2x square minus 7x plus 14, right? So this is the factorization. So x minus 2 into x square minus 7 is the yeah. So this is the factorization now. So hence, what is numerator and denominator? Simply write. So numerator is x minus 2 times x square minus 7, and denominator is, what was denominator? X minus 7 and x plus 2. Oh, so there is no common factor. Okay, so it happens. So yeah, correct. So x into x minus 2 by x plus 2. No, x minus 2. I'm sorry. Sorry. A 7 and minus 2 are the roots. No, you should. Mansi was saying that minus 2 was the root. So that was the mistake. Okay. This is not the case. This is 7 and minus 2. 7 and minus 2 are the roots. So if I check x equals to 2, I checked also, I got 0. Okay, let me check x equals to minus 2. So minus 2 gives you 4, and 7 into minus 2 and minus 2. So let's say x equals to minus 2. Let me check x equals to minus 2. X equals to minus 2 will give me minus 2 square minus 7 into minus 2 plus 2 into minus 2 minus 14, which is 4 plus 14 minus 4 minus 14. 2 into minus 2 minus 4. Yeah. So this is x minus 2 also is a root. So it has to be divided by x plus 2. Sorry. So let me do it afresh. Yeah. Let me do it afresh. So let me just copy it. Okay, let me take it to. So now, so what was it? So we just found out that this is nothing but, so 7 and minus 2 were the roots of denominator. Roots of denominator. And hence x plus 2 is a factor of denominator. So denominator was, d was nothing but x plus 2 times x minus 7. X plus 2 times x minus 7 is the denominator. Am I right? X plus 2 and x minus 7. So it's minus 7 plus 2 minus 5. Yeah. So this is it. Now, if I checked with x equals to minus 2 in the numerator was, I checked minus 2 there. So minus 2 cube minus 2 into minus 2 square minus 7 into minus 2 plus 14. Okay, so this is 8 minus 4 into 2, 8 plus 14 plus 14. Okay, so this is, yeah, so 2 is not the, minus x plus 2 is not the root of this thing. Okay, so actually there is no common root. Wait a minute. And then 7, did you check 7? 7 also won't work, I believe. So yeah, so 7 into 7 cube is 343. Yeah, 343 minus 2 into 49, 98, minus 7 into 7 is 49, plus 14. So it doesn't work. So none of the roots. So hence it is not reducible. Sorry. So I was, while framing, maybe I missed one factor, and hence it is. So it is not reducible. There is no common factor actually. No common factor. No common factor for the two expressions. Try solving the second one. Try solving this one. So what will it be reduced to? Second one. Did anyone solve second one? I think Arpita solved the second one, right? Arpita, what is the second one's answer? Question was x cubed minus 5x square minus 2x plus 24. Would anyone solve the second one? Third one is x square minus 1, correct? Second one is also not reducible. Could anyone reduce second one? So if you see in the denominator, let me just copy the second one. X plus 2 by x minus 1, Momika says. Let me check. This is the second one. Okay. So if you see, in the denominator, if you put x equals to 1, you will get 1 cube minus 8 into 1 square plus 19 into 1 minus 12 is nothing but 1 minus 7, 7 plus minus 7 plus 19 plus 12 minus 12 equals to 0. So that means x minus 1 is a factor of the denominator. Denominator was x cube minus 8x square plus 19x minus 12. Let's multiply. So it will be multiplied by x square. You will get x cube minus x square here. This one is plus, so it becomes minus 7x square plus 19x minus 12. Then you multiply by minus 7x, you will get minus 7x square, then plus 7x, and subtract. So this is minus, this goes 19 minus 12 becomes 12x minus 12, and hence it will be plus 12. You will get 12x minus 12, 0. So hence you see what denominator is x cube minus 8x square plus 19x minus 12 is equal to x minus 1, and x square minus 7x plus 12, again split the middle term, you'll get x minus 3, x minus 4. Okay, now check. Let's check. One of the once we put 1 in the numerator. So in numerator, put x equals to 1. So you will get 1 minus 5 minus 2 plus 24 is not equal to 0. That means x equals to 1 is not a root. So x minus 1 is not a factor. Let's check 3. So 3, x equals to 3. If you put, it will be 3 to the power 3 minus 5 into 3 square minus 2 into 3 plus 24, which is nothing but 27 minus 45 minus 9 plus 24. So 20 plus, am I right? 27 minus 18. So 27 plus 24 is 51. Am I right? We did something wrong. So 3 cube is 27 minus 5, 3 square, 5 9s are 45 minus 2, 3. Oh, sorry, this is 6 and plus 24. Okay, so hence 45 minus so 51 minus 51 equals to 0. That means x minus 3 is a factor. Is a factor. Is a factor. The moment I get x minus 3 as a factor, I can divide. So that's what we did so far. So hence x minus 3 and then divide x cube. No, what is that? X cube minus 5x square. So x cube minus 5x square minus 2x plus 24. Let's divide. So x square times it will go. So x cube and minus 3x square it will be. So it will become plus. This goes and this becomes minus 2x square minus 2x. Then you multiply by minus 2x here. Minus 2x here. So you'll get minus 2x square plus t to the 6x. And this becomes minus, this goes, becomes minus 8x plus 24. And this will be minus 3, I believe. No, sorry, minus 8. Minus 8. Am I right? Looks like, yeah, 8 and then minus 8x plus 24. Right? So hence numerator is x minus 3 and x square minus 2x minus 8. Again, I can split the middle term. It can give me x square minus 2x plus 2x minus 4x minus 8. So this is x minus 3 and this is x plus 2, x minus 4. Right. This is the numerator and denominator was, this is the numerator and denominator was, d was, where was d? D was, yeah, here. So d was x minus 1, x minus 3, x minus 4. So hence answer will be n by d is equal to, so this goes, this goes, this goes, this goes. What's the third question? So third question was this. X to the power 8 minus 1. All of you got it? X to the power 8 minus 1 divided by x to the power 6 plus x to the power 4 plus x to the power x square plus 1. Here is the third question. Third question is this. Sushant got it, I think. Okay. Any other question, guys? Or I'll give you some more. In this topic, any other problem? Okay, so apart from this, there is linear equation, right? So let me give you pair of linear equations you have. Yes or no? Can someone just answer? You have pair of linear equations as well. Okay, so do I need to solve the third one? Anyone wants the third one? Basically, x to the power 8 minus 1 is nothing but, you can express that as x to the power 4 minus 1 into x to the power 4 plus 1. and then x to the power 4 minus 1 can be expressed as x to the power 2 minus 1 and x to the power 2 plus 1, and then you'll get simply x square minus 1 as the answer. So just let me know if you want me to solve it. I'll solve it. So let me give you this problem to solve. Solve this. Solve the pair of linear equations now. Solve 2 upon root x plus 3 upon root y equals to 2, and then 4 upon root x minus 9 upon root y equals minus 1. 2 upon root x plus 3 upon root y equals to 2. 4 upon root x minus 9 upon root y equals minus 1. Solve. Okay, so third question I'll have to solve. Third question I'll solve. So the question was, so those who are doing linear equation can solve this. I will solve the third one. Third one was x to the power 8, and it was minus 1 divided by x to the power, I believe, 6 plus x4 plus x square plus 1. Okay, so this is nothing but x to the power 4 minus 1 and x to the power 4 plus 1 divided by x to the power 6 plus x to the power 4 plus x to the power 2 plus 1, which is equal to x square minus 1 and x square plus 1 and then x to the power 4 plus 1 divided by x to the power 6. So what you can do is you can take common from here also. So x to the power 4 common, it becomes x square plus 1 and plus 1 x square plus 1, which is x square minus 1 x square plus 1 x to the power 4 plus 1 divided by x square plus 1 and x to the power 4 plus 1. So we see this goes. So x square minus 1 is the answer. X is 4 and y is 9. 1 by 2. X is 4 and y is 9. 1 and 2, 1 plus 1, 2. Yeah, okay. X is 4. So 2 minus 3 minus 1. Yeah, correct, Ronak. That's okay. Okay, so next would be, try this. 1 upon 3x plus y plus 1 upon 3x minus y equals 3 by 4, and 1 upon twice 3x plus y minus 1 upon twice 3x minus y equals minus 8. This is in NCERT also, so you can solve this, I believe. 1 by 3x plus y plus 1 by 3x minus y equals 3 by 4. 1 upon 2 3x plus y minus 1 upon 2 3x minus y is minus 1 by 8. So these are not linear equations, but they can be reduced into a pair of linear equations. x equals 1. Is it? And what's y? X is 1 definitely, and y is also 1. Yeah, x1, y1. Ronak, how did you get 3? Yeah, x is 1, y is 1. Good. So let us proceed. So you need to do what here? The common thing is this is not a linear equation, but it can be transformed into one by taking 1 upon 3x plus y as u and 1 upon 3x minus y as v. Correct? So you will get u plus v is 3 upon 4 and 1 upon or sorry u by 2 minus v by 2 is minus 1 by 8. Yeah, so u minus v is minus 1 upon 4. So if you add these two, this one and this one, add 1 and 2, you will get 2u is equal to 3 by 4 minus 1 by 4 is 2 by 4, that is 1 by 2. Yeah, so u is 1 by 4. Right, so when u is 1 by 4, u is 1 by 4, v is 3 by 4 minus 1 by 4, which is 1 by 2. So that means, so what was u? U was 1 upon 3x plus y. So 3x plus y is 1 upon u is 2. And 3x minus y is 1 upon v is equal to, I'm sorry, this is 4 and this is 2. Yeah, so add them, you'll get 6x, 6, this implies x equals 1. And if you put 1, x equals to 1, you will get y equals 1. Okay, next, let us revise the cross multiplication method. So you remember cross multiplication method is simply this. First of all, you have to write, I'm just recapping it so that you don't forget. So let's say it was a1x plus b1y plus c1 equals to 0. First of all, write everything in the left hand side, nothing on the right hand side. Let 0 be on the right hand side. Then a2x plus b2y plus c2 equals 0. Okay, once you have written this, then simply you have to write x, y, x, y1, and then here you start with b1, b2, c1, c2, a1, a2, and again b1, b2. Okay. So now next is you do this calculation. So this is x upon, you have to write b1 c2 minus b2 c1 is equal to y upon, so again y upon c1 a2, y upon c1 a2 minus c2 a1 is equal to 1 upon a1 b2, a1 b2, so again minus a2 b1. So from these two you can write x equals b1 c2 minus b2 c1 upon a1 b2 minus a2 b1. Okay, and y equals c1 a2 C1 A2 minus C2 A1 upon A1 B2 minus A2 B1. This is what you have to remember. Yeah, so just let's do one practice problem so that it stays in your mind. So solve this pair. Pair is 2x plus 3y is equal to 17 and 3x minus 2y is equal to 6. Solve this using cross multiplication so that your revision, you revise this concept. Yeah, x is 4 and y is 3. Correct. So in this question, you had to take 17 on the other side. So that was the, so please be very careful while solving questions. So first of all, make sure that all of them are in one place. 2x plus 3y minus 17 equals to 0. And then do 3x minus 2y minus 6 equals to 0. Yeah, follow this and then only you solve. Okay. So I believe, we had done this thing again, linear equation in the last revision class on Saturday, I believe. So that's also whenever we did it. So linear equations are done. Any problem in matrices? You have matrices also, right? Matrices, linear equations, and any particular part in linear equation. So you please remember, this is, in the nutshell, if I have to give you, this was the total thing which we studied. One was the consistency, inconsistency. So basically, this is, yeah. So let's say there are pair of linear equations were a1x plus b1y plus c1 equals to 0. Then another one was a2x plus b2y plus c2 equals to 0. And then we said that if a1 by a2 is not equal to b1 by b2, then it is consistent. Consistent pair, consistent system of linear equation. And unique solution. This is a case of unique solution. Unique solution or intersecting lines. Correct? Intersecting lines. Then we said that a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Infinitely many solutions. Infinitely many solution. Or we say coincident line. Okay, and then third criteria is a1 by a2 equals b1 by b2 not equal to c1 by c2, parallel lines. And then we also said inconsistent system. Inconsistent system of linear equations, and we said no solution. No solution. No solution existed. Okay? Or right, so this was about consistency. Then we saw, then we say then we saw how to solve solution. How was solution done? One was graphical, so you have to plot the two graphs, and wherever they intersect, that is the solution. So this is my graph. Let's say this is line 1, this is line 2, so this point is my intersection, this point is solution, like that. Okay, then we had algebraic methods. Algebraic method, first one was substitution. Yeah, so what all methods did we learn? We learned first one is substitution. Substitution. Second one is elimination by equating the coefficients. Elimination. Then third one we saw cross multiplication. Cross multiplication. And then fourth one were non-linear equations. Non-linear equations transformed into linear one. Transformed into linear. Into linear. Example was we just solved one, but this kind of a problem. 1 plus x plus 1 by y is 2, and 2 upon x minus 3 upon y is equal to 7. These are non-linear equations, but they can easily be transformed into linear by assuming what? U equals to 1 by x and v equals to 1 by y, like that. Yeah, so these are non-linear equations transformed into. Yeah, they can give you similar such problems. You know, it can be 1 by under root x. We just solved 1 by under root y is equal to 1, and then 3 by root x minus 4 by root y equals to 2, like that. These are all non-linear equations, but they can be transformed into linear ones. That's all. And then there were word problems around that, and that's what was total in linear equations. So I believe you are good now, and solve as many, you know, if you have previous year papers on these two topics, you can solve. If at all you have any other problem, you know what to do. You can always touch base with me. You can send your queries, and I'll be solving them back, and because you have day after tomorrow exam, right? So or whenever tomorrow. So till the exam happens, you can always send me the questions, and I'll solve and give it back to you. Any other problem? If any other specific thing you have, you can. Otherwise, I would suggest you guys practice more, and you know, try and revise all the chapters by taking some solved examples from all the you know, your textbook or Adi Sharma, whichever way. Pick up some solved examples and solve them. And if in case you are getting stuck, you go through the solution and keep that solution in mind. Anything else? So I think we are good, and wishing you all the best. You guys can, if you have anything else, you can just mention. Otherwise, we'll call it a day. And I would expect you to practice. And there are a few things in the exam. You know, I have already reiterated that spare some time, some around 10 to 15 minutes for revision. Please make a mark on the answer script whenever you are solving the question paper. You know, those questions where you think you should be coming back, you just mark those questions, and spare some 10-15 minutes towards the end to come back to those questions and you know, revise them. Because, and especially where there is lots of calculation involved in linear equation, you will see that wherever there is lots of calculation involved, especially in word problems and all, please make sure that once done, you again revisit it if time permits, as much as possible. But it is always a good habit to divide the time accordingly. So you take away 20 minutes out of your total schedule. So let's say you have to solve the paper in 160 minutes, divide the time accordingly. So 1 hour, how many problems you will be solving, you will be knowing. And then, try to finish it within 2 hours and 40 minutes. And the last 20 minutes, please spare 20 minutes to go again and revise, especially those which you have already marked. And if time permits, then go through the entire paper once more. This will reduce your calculation errors. And you know the target. So whatever is the full marks, you have to get around 90% plus of that. So that's the target. And I think all of you are good. You have done enough practice, and this thing you should be getting it. So I'll call it a day then. So there's no further question. Then please, spend time in, quality time in problem solving and practicing more and more. So thanks for joining this session, and we'll be resuming next week once your exams are over. Thank you and all the best.